Okay, so your final will be a week from today. So it will be next Thursday. From 8:30 to 10:30. Okay, so there is more examples on Blackboard. So we will just go over them. Okay, so first question here is asking which statement is equivalent to A and B? Well, if you look at the following choices, you have negation of A implies not B. Well, we know A implies B is congruent to not A and we have not A or B. So we know the third choice is wrong. And it cannot be the second and last choice since you have the N there. So if you check the first one, then A implies not B will congruent to not A or not B. Now to negate it, if you apply De Morgan's law, then you will negate each part here. So you have A and B. Now you will flip the OR to AND by flip the disjunction to conjunction. So this is the answer. The first choice. Any questions here? Okay, now we will move on. Now the next question is asking the product of two negative real number is not negative. Now, which of the following propositional logic, it's equivalent to this statement. Well, you want to have a product of two negative number. It's not negative, that means it will be positive. Right, so that means for any, right, so it will be for all x and y that will, so x and y will represent the real number. So you will have for all x and y, right, any negative real number. So to have n to be negative, you have x less than 0 and y less than 0, since you need both number to be negative. And you want to show the product of them is not negative. And not negative means it's positive, which means it's greater than 0. So the answer choices will be the third one here. Oh wait, it will be the first one. For all x and y, x less than 0 and y less than 0 implies x times y greater than 0. Okay. Now here it asks you to translate this propositional logic. So we have for all x, or you can say for each x, there exists a y where x is less than y. So you want to find where do you see for all x there exists a y such that x is less than y. So that will be the last choices there. Okay, now here is asking which of the following can only be used in disproving a statement. So what do we use here to disprove a statement? Counterexample. Right, just provide a counterexample. So if you can find any counterexample in a statement, that means your statement is wrong, you disprove it. Right, or other is a proof method. You want to show a statement is true. Okay, next. To prove that square root of 5 is irrational, we begin with the assumption that square root of 5 is rational. Which type of proof is this? So you start with negating the statement. So that will be contradiction. Okay, next we have if n is not an odd integer, then the sum of n with Then the sum of n with some not odd number will not be odd. Now here, you have if n is an odd integer and Qn to be sum of n with some not odd number will be odd. Now it's asking which of the following provide by contrapositive of the statement. So if you look at the statement here, right? So the if part is a negation of Pn. And then the conclusion part is a negation of Qn. So this statement here can be translated to negation of Pn implies negation of Qn. Now the question is asking to provide the contrapositive version of the statement. So contrapositive means you will negate your if and then statement and then you will flip them. So you have, so to negate Qn, you have Qn, then implies Pn. Any questions here? And now next, it's asking the set of real number between 1 and 2 is which kind of set? Well, we know for the real number between any interval, it will be uncountable set. But we just check the real number between 0 and 1. So similar for real number between any interval. So it will be an uncountable set. Okay, now here you're asking x is an integer that's neither positive nor negative. Then what's your set? How many integer that's neither positive nor negative? There are one of them, right? So that will be 0, the set of 0. 0 is neither positive nor negative. So this will be a set containing 0, so it will be a finite but not empty set. Okay, now here it's asking which of the following is true. Now, is the set containing 2 an element in A? Now, if you check it, there's no element with the set containing 2. Now, here's asking, is 3 a subset of A? Well, in order to be a subset, itself need to be a set. 3 is not a set, so it's wrong. Now, is empty set a subset of A? The answer will be yes, right? Empty set it's a subset of any set. Now here you have the set containing empty set and the set containing empty set is an element of A. Now it will be wrong. Right? You don't have element with this choice. In fact, the bracket here is not even matched. So the answer is this one. NT said it's a subset of A. Okay, here, so we want to find the set A minus B. So the A minus B means an element that's in A, but that's not in B. So if you look for the element that's in A, but not in B, 1 is not in B, but it's in A, 2 is in B, 3 is in B. So your set will just be the set containing 1. Okay, next, you'll have two sets A, B contains B, A and B element respectively. And if the power set of A contains 16 more elements than B, now it's asking what's the value of B and A respectively. So we have two sets. Set A have A element. Set B has B element. And you know the power set of A contains 16 more elements than B. So power set of A contain 16 more elements than B. So which means power set of A equals to B plus 16. Now it's asking which of the following can represent the B and A. Well, if set A have A element, how many elements does power set of A contain? Actually, here it should be if you compare power set of A and power set of B. How many elements, how do we find power set of A? How many elements in power set of A? Anyone? How do we find number of elements in the power set? 2 to the n. So we know power set of A will contain 2 to the A element, and power set of B will contain 2 to the B element. Now you know power set of A will equal to 16 more than power set of B. So what's the value of A and B? it will be 4 for the B and then A for the fifth power. Since you want to add up to 2 to a power, and we know 16 here is 2 to the fourth. So B here are kind of forced to be 4. So 2 to the fourth plus 2 to the fourth, it will be 2 times 2 to the fourth, and that will give you 2 to the fifth. So A will equal to 5. So the answer will be 4 and 5. Any questions here? Okay, now here it's asking it's asking how many elements is in power cell of A. Now if you look at A, so if you count how many elements in A, you have 1 element here, then you have 1 element here. So you know set A have only 2 elements. And since set A have only 2 elements, then the power cell of A will have 2 square elements, so that will be 4 elements. Okay, now here it's asking if A is a subset of B, B is a subset of C, then what's the cardinality of A union B union C equals to? Well, if you draw a Venn diagram, you have A, it's a subset of B, so you know A is inside B. And then you have B is a subset of C. This is inside C. Now we will take the union of all of them. That means you have a set where as long as your element is in one of the set, it will belong to the union. But everything's contained in C, so you know this will equal to cardinality of C. Okay. Now here we have if the cardinality of A union B equals to cardinality of A plus cardinality of B, what does it mean? Well, normally when we find cardinality of A union B, this will equal to cardinality of A plus cardinality of B, and we also need to subtract the overlap. But now, since your cardinality of A union B just equals to cardinality of A plus cardinality of B, this means your cardinality of A intercept B is equal to 0. And this means they don't have anything in the intersection. So A and B are disjoint. Okay. Next. Okay, so here it asks, which of the following is the base case for 4 to the n plus 1 is greater than n plus 1 squared whenever n is greater than 1? Well, for base case, we always check the very first case. Now, the first integer that's greater than 1, then it will be 2. Now, if you substitute 2 in, then you have 4 to the 2 plus 1. It's greater than 2 plus 1 squared. Then you have 4 cubed. You want to show 4 cubed is greater than 3 squared. And 4 cubed will give you 64. And 3 squared will give you 9. So you know the answer will be 64 greater than 9. Okay, now here's asking which of the following statement cannot be proved by methods of mathematical induction. Now we assume n is an integer. Well, we know the only time you cannot use mathematical induction to prove a statement is when the statement is wrong. So if you look at here, you want to check n factorial. So first one is to show n factorial divides 2 to the n minus 1 for n greater or equals to 2. Okay, so let's check. Well, when n equals to 2, you have 2 factorial, which is 2, and then 2 to the 2 minus 1 will be 1. So 2 divides 2, check. Now just check one more case when n equals to 3. You have 3 factorial, which is 3 times 2 times 1, right? So that's 3 factorial. And you want to show 3 factorial divides 2 to the 3 minus 1, which is 3 squared. So 3 factorial will give you 6, and 2 squared will give you 4. That's 4 divides 4. That's 6 divides 4. The answer will be no. So here we found a counterexample. Now let's just check the other one. You have 2 to the n plus n factorial. Now you want to show this is even for n greater or equals to 2. Well, 2 to any power is always even. Now, n factorial when n greater or equals to 2, that means 2 is always a factor in 2 factorial, since you have n times n minus 1 and so on down to 1. Now, if your n is greater than 2, that means when you keep multiplying the number, 2 will be one of them, so n factorial will always be even. So even plus even is even. So we know this is true. Then the next one, 2 to a power congruent to 0 mod 4 for all n greater or equals to 2. Again, we have 2 to a power where the power is greater than 2. You can always factor out a 2 squared, and the 2 squared is 4. 4 mod 4 give you 0. So anything times 0 will give you 0. So we know this is true. Now, n factorial is greater than 2n for all n greater or equals to 4. I believe we proved this in class. Okay, then we will move on. Now here's asking what's the quotient and remainder when -1 divided by 3? Well, to find quotient and remainder, that means now our divisor is 3, and you want to find quotient and remainder. And you want the remainder to be greater or equal to 0 and strictly less than the divisor, which is 3. Well, if you let Q to be 0, then your R will be -1. So it cannot be 0. So you will force Q to be -1. Now when Q is -1, you have -3. Now to make it -1, your remainder will equal to 2. So the quotient will be -1. The remainder will be 2. Okay, so here we have, if A divides B and A divides C, we show the following is true. Well, if you check A plus B divides C, so let's check. So we can have, well, let's do like an easy one. So we know 1 divides everything, right? 1 will go into everything. So we know 1 going to 3, 1 going to, let's say, 5. Now that's 1 plus 1. Wait, let's do another one. So want to find A divides B, A divides C. Now want to check is A plus B divides C true. So let's show we can have 2 divide 6, and we can have 3 divide 6. And when we do 2 plus 3 divide 6, we have 5 divide 6, which is false. So you know this is false. Now let's check A times B divides C. So let's look at 2 divides 12, and we know 4 also divides 12. But if you multiply, then 2 times 4, it will be 8. 8 does not divide 12. So we know this is also false. We can find counterexample. And then we want to check their difference. Again, if we check 3 divides 6, wait, let's do okay, so we know 6 divides 6, and we know 2 divides 6. But if we check 6 minus 2 divides 6, 6 minus 2 give you 4. 4 does not divide 6. So this is also a counterexample. So we know none of them is true. Any questions here? Okay, next is asking number of positive factors of a prime number. How many positive factors does prime number have? It will be 2, right? And what are the 2? 1 and itself. So the answer is 2. Okay, now, if you have A, B, C, D are distinct prime, and you know A is the smallest prime number, what do you know about A times B times C times D? What is smallest prime number? It was 2. Now if 2 is one of the factor, then what do you know about A times B times C times C? It's an even number. Okay, next it's asking what's the last 3 digit of 1998 to the 8th power? Well, to find the last 3 digit number, that means we are doing mod 1000. Now, what's 1998 mod 1000 congruent to? Anyone? Can you find another number that's congruent to 1998 mod 1000? Okay, so if you say 998, any number smaller because you don't want to compute 998 to a power, right? So it's congruent to -2. Now, if you can replace it with a -2, what's -2 to the 8th power? So the answer will be 256. Okay, next. So here you have a Chinese remainder theorem question, where you have x is congruent to 4 mod 5, x is congruent to 7 mod 8, x is congruent to 10 mod 11. Well, we know according to the Chinese remainder theorem, if your modulus is not is pairwise relatively prime, then you know there will be a unique solution modeled by product of them. So if you check 5, 8, and 11, none of them share a common factor, so they are pairwise relatively prime. So you know there will be a unique solution modeled by 5 times 8 times 11. And here give you 5 times 8 times 11. It's 440, so you know there will be a unique solution mod 440. Okay, so people are asking why do we have 256? Because 1998 mod 1000 is -2. And -2 to the 8th power is 256. Okay, next. So here, if we have A and B are both positive integer, and the GCD of A and B is 8, then what do we know about the following? So if you look at it, we want to find what's A plus B. Well, if A and B are both positive integer and their GCD is 8, that means both numbers are multiple of 8. Now, when you adding two numbers are multiple of 8, A plus B will also be multiple of 8. Now, if you look at it, can A and B ever congruent to 4 mod 16? The answer will be no, because 4 mod 16 it's not multiple of 8. Now, if you look at here, it says cannot determine as A in 16 because A in 16 are not relatively prime. Well, if you look at 16, 16 is also multiple of 8. So if you look at it, the next one, we have A plus B is congruent to 8 mod 16. Well, not only 8 mod 16 can also be 0 mod 16. You can also get 16. If A and B are both 8, it will also have GCD of 8. Okay, so the answer will be A plus B can congruent to 0 or 8 mod 16. Right, since both outcome are possible. And that's because their GCD is 8. So you know they both multiple of 8. Now, how do you represent multiple of 8? 0 mod 8. Now, which of the following that's equivalent to 0 mod 8? 0 and 8 mod 16. Okay, next is asking, according to the Fermat-Theodore theorem, which of the following is the inverse of 2 mod 83? Well, according to the Fermat-Theodore theorem, we know 2 to the, well, 83 is a prime. So 2 to the 82 will congruent to 1 mod 83. Right, so this is what you know from the Fermat-Theodore theorem. Now you want to find inverse of 2. Inverse of 2 means 2 times the inverse will give you 1 mod 83. Now, if you know 2 to the 82 is congruent to 1, then what number do you multiply here to get 1 mod 83? Or since you already know 2 to the 82 is congruent to 1, then you can break it down. Okay, or you can factor out 2 from 2 to the 82. So here you will have 2 to the 81. Right, because 2 times 2 to the 81 will congruent to 1 according to the Fermat-Theodore theorem. And if it's congruent to 1, then you know inverse of 2 is 2 to the 81. Any questions here? Okay. Again, the question is asking, according to the Fermat-Theodore theorem, which of the following is the inverse of 2 mod 82? Well, we know according to the Fermat-Theodore theorem, if you are modding a prime, which 82 is a prime, then, and also 2 is not congruent to 0 mod 83. So 2 to the prime minus 1, which is 82. So you know 2 to the 82 is congruent to 1 mod 83. This is according to the Fermat-Theodore theorem. Now you want to find inverse of 2. Inverse of 2 means 2 times its inverse will congruent to 1 mod 83. Now how do you find number? Well, since you already know 2 to the 82 is congruent to 1 mod 83, then if you break it down, then 2 times 2 to the 81, that will give you 2 to the 82, which is congruent to 1 mod 83. So since 2 times 2 to the 81 is congruent to 1 mod 83, the inverse of 2 will be 2 to the 81. Since when you multiply it, you get 1 mod 82. So the inverse will be 2 to the 81. Are we good here? Okay. Next is asking, suppose ax plus 5 is divisible by 69. And that's asking, can x divisible by 10? which means, can you find an x where you know ax plus 5 is congruent to 0 mod 69? Right, since ax plus 5 is divisible by 69. So if it's divisible by 69, then it will congruent to 0 mod 69. You have remainder of 0 when you divide it. Now you're asking, can you have this x also congruent to 0 mod 10? Well, can you find a solution for the ax congruent to 8? Ax plus 5 congruent to 0 mod 69. Or if you move around, you have ax congruent to -5 mod 69. Well, we know this will have a solution since the GCD of 8 and 69 is 1. So you know there will be a solution, x congruent to something mod 69. Now, can you find a number that's both something mod 69 and congruent to 0 mod 10? Now the answer is also yes, because according to the Chinese remainder theorem, you can find a number that's something mod 10 and something mod 69 since GCD, right? Since 69 and 10 are relatively prime. So you don't need to solve it, but you know there is a solution. Right, so first of all, you know you are able to solve this linear congruences. So you know x will congruent to something mod 69. And you want to find the x that's congruent to 0 mod 10 at the same time. And we know it's possible by Chinese remainder theorem. And since this is a true-false question, you just need to know, does there exist one? You don't need to actually solve it. Okay. Okay, the next one is asking what does the inverse of 46 mod 98 exist? And we know the answer is no. Again, you check the GCD. GCD of 46 and 98. It's obvious that the GCD is not 1 since they are both even number. So the GCD is at least 2. And if the GCD is other than 1, then the inverse does not exist. Okay, and the next one you have if the cardinality of the intersection of two countably infinite sets must be countably infinite. Is it true? Well, the answer is false, right? So if you take positive integer, you know it's countably infinite. And then you can have another set that's negative integer that's also countably infinite. Now, when you take positive integer intersect with negative integer, they have nothing in common, right? So the intersection is an empty set. It's not an infinite set. So you can easily find an example, counterexample. Okay, so here you have the function f of x equals to x plus 1 is from the set of integer to itself. So from the set of integer to an integer is surjective. Is it true? Well, you have f of x equals to x plus 1. Now to show it's surjective, that means for all b, there exists a where f of a equals to b. Well, you want to solve for B, right? So for all B, you want to solve for A. Well, A here will be A plus 1 equals to B. Then for all B, you can find A where A equals to B minus 1. And since B is an integer, integer minus an integer, right? Integer minus 1 is also an integer. So we know this is true. Okay, so next is asking if A divides B plus C, if and only if A divides B and A divides C. Is that true? We know if A divides B, A divides C, then A divides B plus C. Now, is it true vice versa? If A divides B plus C, is it true that A divides B, A divides C? Okay, I already see people say the answer is false. Again, we can provide a counterexample. 3 divides 2 plus 1, or 3 divides 3. But 3 does not go into 2, 3 does not go into 1. So the answer is false. Okay, next. Here we have negative 102 is congruent to negative 6 modulo 16. Now I want to check, is this true? Okay, so we have negative 102 mod 6. Well, we can keep, okay, since we want to bring it up to negative 6, so you want to keep adding. Well, if you add, okay, mod 16. So if you add 160, then you will get 58. Well, 58 is too large. Then you want to check, is it congruent to negative 6? Or another way you can do, right? So pretty much it's asking, is negative 102 congruent to negative 6 mod 16? So you check the difference. Between negative 106 and negative 6. And that will give you negative 96. Now I want to check the 16 go into 96, negative 96. The answer will be true. Negative 96 is equal to 16 times negative 6. So we know this is true. Okay, next. We have if A is congruent to 3 mod 3, and B is congruent to 2 mod 6, then A plus B is congruent to 5 mod 6. Is that true? Well, if you just check, what's 3 mod 3? If A is congruent to 3, if you just do 3 plus 2, then you can get 5 mod 6. Because A can be 3. Now, what else can A be? 3 mod 3 can also congruent to 0. Right? 3 mod 3 is 0, is congruent to 0 mod 3. So A can also be 0. Now, if A is 0, then 0 plus 2 will congruent to 2 mod 6. So we know the answer is false. Okay, next. Now it's asking does these linear congruences have solution? And we know to check whether linear congruences have solution, you check the GCD. So you check what's the GCD of 96 on 30, you check the GCD of 39 and 45. And GCD of 39 and 45, it will be 3. Now if you check, does 3 divide 7? The answer is no. So since the GCD does not divide 7, there's no solution. Okay, and next it's asking what's the cardinality of this set. So if you count the number of elements in the set, you have 1, 2, 3, and then 4. So you have 4 elements in your set. The answer will be 4 here. Okay, next it will be GCD. Well, to check the GCD, you can do the Euclidean algorithm. So 153 will go into 252 one time with a remainder 102. And 102 will go into 153 once with a remainder 51. And 51 will go into 102 twice with a remainder 0. And once you hit 0, you know the GCD is 51. Okay, next. It's asking you to find a x in between a and 18 that's congruent to negative 155 mod 9. Well, negative, you know, x is congruent to 155 mod 9. Now we know to find number in the same congruent class, we can keep adding or subtracting multiple of 9. Well, let's add 180. If you add 180, right, 180 is 9 times 20, right? So that would be multiple of 9. So if you add 80, you will get 25. Now 25 exceed our range, right? We want to find a number between a and 18. So since it's too large, we will subtract it by 9. So if we subtract it by 9, we will get 16. So we know x is congruent to 16, and 16 is in this range. So the answer will be 16. 16 will congruent to negative 155 and it's in this range. Okay. And next, find x where x is congruent to 9753 mod 120, where you want to find x in the range of negative 120 and 0. So again, you have x congruent to 9753 mod 120. Now you want to find a number in between negative 120 and 0. So we can add and subtract multiple of 129. And I see people say we can subtract 9600. So 9600 is multiple of 120. Right, if you multiply it by 80, you will get negative 9600. So if you subtract that, you will get negative 153. Now it's not big enough, but we want to find the number in the range of negative 120 and 0. So you need to add, here it's, actually it's positive here. So you have positive 153, so it's still too large. So we need to subtract. So if you subtract 120, your number is still in the positive range. So you need to subtract that twice. So you subtract that. So you subtract 240. If you subtract 240, that will give you negative 87. So the answer will be negative 87. Okay, next, it's asking you to reduce 3 to the 2020 power mod 7. Well, let's look at some, well, we know 7 is a prime. So according to the Fermat's-Lillo theorem, we know 3 to the 6 is congruent to 1 mod 7. So we can check. So we can put 3 to the 2020. That's 3 to the 6, and then see how many times the 6 go into 2020. Right, so it will go into it. Three. Oh, 3, and let's see, if you take it will give you 336. And it will give you a leftover of 3 to the 4th. And 3 to the 6, again, it's congruent to once you have 1 to the 336 times 3 to the 4th. Right, and 3 to the 4th, that will give you 3 times 3 times 3 times 3. So that will give you 81. And 81 mod 7, but if you can subtract 70, and that will give you 11. If you can subtract 7 again, and that will give you 4. So you know this is congruent to 4 mod 7. So the answer will be 4. Any questions here? Okay, we will move on. Next, we will find inverse of 25 mod 27. Well, inverse means you want to find a number that multiply 25. That will give you 1 mod 27. Okay, I see people say the answer will be 13. Well, if you look at 25 mod 27, 25 can be reduced to -2. Now -2 times 13, or -2 times -14 will give you +28. And 28 is congruent to 1 mod 27. And the 14 here will congruent to 13 mod 27. So 25 times 13 will congruent to 1 mod 27. Or you can just solve it by the Euclidean algorithm. So you have 27, and then see how many times 25 go into it. It will go into it once with a remainder 2. And then 2 will go into 25 12 times with the remainder 1. Now, if you doing the process backward to get the linear combination, and then you substitute the 2, you have 25 times 1, and then here you have -1 times -12. That will give you 13 plus 27 times -12. And the inverse will be the number you since you want to find inverse of 25. So the inverse of 25 will be the number you multiply with 25. So that will be 13. So you know the answer here is 13. Okay, here you want to find the last 2 digits of this expression. So you have 97 to the 29 plus 99 to the 29 plus 100 to the 29 plus 103 to the 29. Now, since you want to find the last 2 digits, then here you will multiply by 100. Mod 100 give you the last 2 digits. Now, if you reduce here, 97 mod 100, that will give you -3 to the 29 power. 99 mod 100 give you 1 to the 29. 100 mod 100 give you 0 to the 29. 103 mod 100 give you 3 to the 29. Well, now if you calculate it, -3 to the 29 will give you -3 to the 29. 1 to the 29, you just add 1. And here you have 0 to the 29. That will be 0. And then you have 3 to the 29. Now, if you solve it, what do you get? There's -39. Okay, here, oh, okay. A 99 mod 100 will give you -1. Not 1. -1 to 100. You have -1 mod 100. So this -3 to the 29 plus +3 to 29, you can cancel it out. So you know this will just congruent to -1. Now -1 mod 100 will give you 99 mod 100. So the last 2 digits will be 99. Any questions here? Okay, next, find the smallest positive x that satisfy these 2 condition. So you have x is congruent to 3 mod 8, and x is congruent to 7 mod 11. Well, according to the Chinese remainder theorem, well, you know, 8 and 11 have GCD of 1. So you know there will be a unique solution modeled by product of them, which will be 88. So you will be able to find a solution between 0 and 87. Well, then you just keep looking for the number. 3 does not work for both conditions, so you keep going. You can, if you add 8 to it, you will get see. You know what? I will start with 7 mod 11 since it generates faster. So 7 does not work for 3 mod 8. So we keep going. So we can get 18. 18 is not congruent to 3 mod 8. So you keep going. So you can have 29. 29 is not congruent to 3 mod 8. If you subtract it by 3, you'll get 26. It's not multiple of 8. Now, if you keep going, you will get 30. 30 is not 3 mod 8, so you keep going. So you have 41. 41 is not congruent to 3 mod 8. If you subtract 3, you will get 38. So it does not work. So you keep going 50. One. Oh, I make a mistake here. 29 plus 11 will give you 41. So 41 does not work. And then if you wait, it will be 40. Wait, 29 plus 11 will give you 40, and 40 does not work. So you keep adding 11. So you have 51. As if you say 51 work. So 51 minus 3 will give you 48. And 48 is multiple of 8. So we find 51 work for both. So we know 51 will be the smallest positive x. That will satisfy the two conditions. So the answer will be 51. Any questions here? Okay, so there are the last two questions. Like one is solving the linear congruences, and one is induction. So I will post the solution up on Blackboard so you can check it yourself. Since I have another class right after, so I can't go over it now. And if there's any question, I will hold another review section on next Tuesday. So next Tuesday is supposed to be a reading day. Okay, so I will hold another review section on reading day. So if you have question, you can come and ask. Okay, CPO say will the final be the same number of questions? It will be similar length. Yes. So this is previous semester's final. So you know how final look like. Okay, so I will end it here and everyone have a nice day. Okay, if there's any question, I will hold another review section next Tuesday. Okay, and your exam will be next Thursday from 8:30 to 10:30. Right, so your exam doesn't start at 9:15. Your exam started at 8:30. So don't be late for your exam. Okay, have a nice day.